All right, think and discuss. Number 101, discuss whether or not velocity of an object can reverse direction while maintaining a constant acceleration. If so, give an example. Velocity of an object can reverse directions. This is if you throw an object straight up into the air. At the peak, the velocity is 0, so basically you're going from a velocity upwards to a velocity of downwards. Acceleration is constant because while it's going up, it's slowing it down. At the peak, it's causing the change in directions, and then it causes the speed up. So throwing an object in the air at the peak. 107, 3 identical blocks are pulled as shown, and then you have the tension on the end. What are the tensions in the other 2 ropes? So for a case like this, we can just make up masses of the objects because they're identical blocks. And so let's just make the mass of each of them 10 kilograms. So the rope on the right-hand side is pulling 30 kilograms. So the acceleration of the blocks is 1 meter per second squared. Now the rope in the middle is pulling 2 blocks to the right, accelerating them at 1 meter per second squared. And so therefore, since the mass it's pulling is 20 newtons, it has to be applying a 20 newtons of force. The block on the left-hand side is pulling only 1 block, and so therefore the tension there has to be 10 newtons because it's pulling 1/3 of what the one on the right is pulling. 111, as you leap upwards in a standing jump, how does your force that you exert on the ground compare with your weight? So this comes down to, this actually contradicts his later definition of weight, unfortunately. But sticking here, he means weight as in the force due to gravity. Now, as you leap upward in a standing jump, the force you exert on the ground is the normal force between you and the ground. The force you exert on the ground is equal to the force the ground exerts on you from normal force. Now, the force you exert on the ground is down. Your weight is down, so they're in the same direction. And the normal force you apply actually will fluctuate. Now, on average, and that's the key thing here, that's what he's going for, on average, you have to exert a greater force on the ground than your weight. Because if I weigh 220 pounds, let's be cool, metric. If I weigh 1,000 newtons, if I push down on the ground with 1,500 newtons of force, that means the ground pushes up on me with 1,500 newtons of force. My weight is 1,000 newtons down, 1,500 up, and I end up with a net of 500 newtons upwards, which allows me to accelerate upwards. That's how I get off the ground, by accelerating upwards. So ultimately, I have to apply some force greater than my weight in order to be able to accelerate upwards. If this one's asked in class, I'll go into more detail and talk about some nuances and about the point. Well, actually, I'll mention it right here. So I apply the 1,500 newtons of force upwards, and I'm accelerating. At some point, the normal force that I exert on the ground is 0. Now, I can't go from 1,500 newtons to 0 without passing, I have to go through the numbers in between. There's no rip in the space-time continuum. And so, therefore, when I leap, at some point, the normal force will be less than my weight. At that point, I will start to slow down, but I'm still touching the ground officially, and I have enough velocity so that I will actually leave the ground. There's a graph that goes along with it if you're interested. So 112, when you jump vertically off the ground, what is your acceleration when you reach the highest point? So assuming that it says off the ground. So once I leave the ground, the only force acting on me is the force due to gravity, and therefore my acceleration throughout the entire time is the acceleration due to gravity. Around Earth, it's about 9.8 meters per second squared. It is not 0, and that's the most common wrong answer there, is that some people feel that when you stop at the peak, your acceleration is 0, and that's not the case. If that were the case, if you're at the peak of a flight, if your acceleration is 0, that means there's no change in your velocity. Since you stop, if your change in velocity is 0, and your velocity is 0, that means you hover, which would be a really cool effect. I suspect that we as a species would have extinguished ourselves, but we have not. It is not the case. And that is the Think and Discuss.